Here's a task for you. Copy phone numbers out of a phone book, by hand, for 15 minutes. Not a phone book you'd scroll through, an actual printed phone book, thousands of names, thousands of numbers, column after column of nothing that matters to you. Just write them down, one after another. Nobody does this anymore, but in 2014, psychologist Sandi Mann at the University of Central Lancashire made people do exactly that. And then, right after, she gave them a creativity test. She put 2 plain styrofoam cups on the table and asked, how many different uses can you think of for these? The bored group, the ones who'd just spent 15 minutes copying phone numbers, crushed it. They came up with significantly more ideas than the control group. Plant pots, drums, makeshift speakers. One person suggested building a Madonna-style bra out of them. That's what 15 minutes of pure, unfiltered boredom did to someone's brain. But Mann didn't stop there. She ran it again with a twist. This time, instead of writing the numbers, one group just had to read the phone book out loud. Passive, even more mind-numbing. And their scores on the creativity test were even higher. Here's what she figured out. When your hands are busy, your mind stays in the room. But when you're just sitting there, bored, with nothing to anchor you, your brain leaves. It wanders somewhere else. And wherever it goes, it comes back with things. Mann described it like this. When we're bored, we're not switched off. We're searching. We can't find anything worth engaging with in front of us, so the brain goes inward. And that's where the interesting stuff starts happening. Most of us treat boredom like a problem to fix. Something's wrong if we're bored. We're wasting time. We're being unproductive. Swipe it away, fill it up, move on. But that reaction might be costing us something we can't easily get back. Think about this for a second. Boredom is one of the oldest human experiences. It's been woven into our biology for hundreds of thousands of years. And evolution doesn't keep things around for no reason. If boredom were simply a malfunction, a gap in our programming, natural selection would have ironed it out a long time ago. It didn't, which means boredom is doing something important. To understand what, we have to go back, way back. Picture our ancestors on the African savanna, not the dramatic version, not the running from lions version, just an ordinary afternoon. Food's been found, no immediate threats. The group has a few hours with genuinely nothing pressing to do. Most animals in that situation do the sensible thing. They rest, conserve energy, stay put. But something happened in humans, and maybe in our earlier ancestors too, that made that stillness uncomfortable. An internal signal started firing, a low-grade itch, a pull towards something else. Something over the next hill maybe, something untried. That feeling is boredom. Cambridge psychologist Brian Little puts it this way. Boredom gives us both the physiological and psychological motivation to search for new activities. Its evolutionary significance, he argues, is that it created the drive to explore. And that drive changed everything. New terrain meant new food sources, new animals, new plants, new materials to work with. The humans who felt that pull, who couldn't sit still when nothing was happening, were the ones who kept expanding their world. The ones who were perfectly content to stay put, stayed put. Human migration out of Africa wasn't just about climate shifts or dwindling resources. It was also about something internal, the refusal to accept that where you are is enough. Boredom, in its most primal form, is the feeling that there's more and you haven't found it yet. That's not a bug. That's the engine of human expansion. But here's where it gets genuinely strange. Boredom doesn't just push us to move, it changes how our brains work. And neuroscientists have only recently started to understand the machinery behind this. When you're bored, really, properly bored, with nothing to distract you, a specific network of brain regions lights up. Researchers call it the default mode network. It activates when your brain isn't focused on the outside world. When there's no task to complete, no problem to solve, no screen to follow. What does this network actually do? It reconstructs memories, it simulates futures, it connects ideas that were never connected before. It lets you step into other people's heads. It's where your sense of self lives. When neuroscientists first noticed this network, they were confused. The brain was burning significant energy doing what looked like nothing. Rest should mean lower activity. But they kept seeing it. The idle brain was quietly doing some of its most important work. Think about the last time a good idea found you. Not when you were grinding through a problem, when you were in the shower, on a walk, staring out the window on a train. lying in bed waiting to fall asleep. That's the default mode network doing its thing. Your brain, freed from the demands of the outside world, starts making connections it couldn't make when you were busy. Stanford neuroscientist Vinod Menon has spent years studying this network. He said it's central not just to creativity, but to identity, to empathy, to the whole inner life we think of as being human. And here's the part that should make you put down your phone. It only works when nothing else is competing for your attention. It goes quiet the moment you open an app. It disappears when you're in back-to-back meetings. The default mode network runs on boredom. Now, back to the electric shock. In 2014, the same year Sandi Mann published her phone book study, psychologist Timothy Wilson at the University of Virginia ran a different kind of experiment. He put people in a plain room. No phone, no book, no pen. Nothing to do for 15 minutes, but sit there and think. Most people hated it. So Wilson added a button. If you pressed it, you'd receive a mild electric shock to your ankle. Nothing dangerous, just a quick, unpleasant zap. Before the experiment, every participant had already experienced the shock. Every single one said they would pay money not to feel it again. Then he left them alone with it for 15 minutes. 67% of men pressed the button. One man pressed it 190 times. We went into this thinking it wouldn't be that hard for people to entertain themselves, Wilson said. We have this huge brain, and it's stuffed full of pleasant memories. We have the ability to construct fantasies and stories. And yet, pain was more tolerable than nothing. This is what we've become, and it's not entirely our fault. Our brains were never built for the kind of constant, on-demand stimulation we now carry around in our pockets. The human brain evolved to respond urgently to novelty. A rustle in the grass, a flash of color, an unexpected sound. In the ancestral environment, ignoring those signals could get you killed. The infinite scroll is built on exactly that wiring. Every refresh is a small gamble. Something might be there this time. Your brain can't look away because your brain was designed not to look away. It's a slot machine in your pocket, and every time you give in, every time you pick up your phone the moment boredom strikes, you rob yourself of something. Not just in the moment, over time. Think about how you handle silence now versus a decade ago. Most people can't sit through a 2-minute wait without reaching for their phone. That's not laziness, that's a trained response. The ability to tolerate boredom long enough for something to happen, that muscle has been quietly atrophying. Alison Gopnik, a developmental psychologist at UC Berkeley, has studied what she calls the explore-exploit trade-off. Every organism has to balance two things, exploiting what it already knows and exploring what it doesn't. Adults are optimized for exploitation. We know things, we have routines, we have efficient ways of getting through the day. Children are optimized for exploration. Their brains are wired to be dissatisfied with the known, to seek novelty, to ask what else is possible. And humans, Gopnik points out, have the longest childhood of any species on Earth by a wide margin. We stay in that exploratory state for longer than any other animal. That's not an accident. That extended childhood is evolution investing heavily in the explore side of the equation. A bored kid invents a game, builds something, asks a question nobody thought to ask. The discomfort of having nothing to do gets converted, automatically, without instruction, into the thing humans do better than any other species: create. And yet, the first thing most parents reach for when a child says, "I'm bored," is a screen. But consider what we might be interrupting. Now, a fair counterpoint. Is boredom always good? No, clearly not. Chronic boredom, the grinding, pervasive sense that nothing you do will ever matter, is linked to depression, impulsive behavior, and worse. There's a reason idle hands have a reputation. When boredom has nowhere to go, when there's no outlet and no possibility of exploration, it curdles. But that's different from what we're talking about. The brief, passing, sitting with nothing kind of boredom, the 15-minute phone book kind, that's not the same thing. That's the productive kind. The kind that quietly recharges something the busy mind has been running on empty. Andreas Elpidoru, a philosopher at the University of Louisville who has written extensively about boredom, calls it a regulatory state. It warns us when the current situation has stopped being meaningful, and it pushes us towards something better. Without boredom, he argues, we'd get stuck. We'd keep doing the unfulfilling thing indefinitely because nothing would tell us to stop. Boredom is the signal that says, this isn't it. History tends to agree. Isaac Newton went home to his family estate when Cambridge closed during the plague. For 18 months, he had nothing to do but think. Gravity, calculus, the theory of light, all of it took shape in that unstructured time. Darwin built a gravel loop on his property he called his thinking path and walked it every afternoon for decades. Not to solve problems directly, to let his mind drift long enough to solve them sideways. Neil Gaiman put it plainly. You have to let yourself get so bored that your mind has nothing better to do than tell itself a story. That's not poetry. That's neuroscience. Here's the thing though, reclaiming boredom in 2026 isn't easy. Our devices are specifically, expensively designed to prevent it. Every notification, every autoplay, every algorithmic feed exists to ensure you never have to sit with nothing. The engineers who built these systems understand the default mode network, and they've built the perfect machine for shutting it down. So the question isn't whether boredom is worth protecting. It is. The question is whether we're willing to actually do it. Not in a dramatic way. Nobody's asking you to go live in a cabin. But maybe the next time you're waiting for something, in line, on the subway, sitting in your car before you go inside, you don't reach for your phone. You just sit there. Let your mind do what it's been trying to do since long before there were phones to reach for. It'll be uncomfortable. For a few minutes, it will feel like nothing is happening. That's the feeling. That's exactly the feeling. Your brain, freed from the noise, starting to work the way it was always designed to work. Boredom didn't hold us back. It's what got us here. And if we keep killing it, one scroll at a time, it might be the most expensive thing we've ever given up.